Hello friends, very good morning. I extend a hearty welcome to my YouTube channel, and in today's video we are going to learn about the projection of a square pyramid which, while resting on one of the corners on HP, the base appears as a rhombus of the given size. Friends, first of all, let us go through the problem and see the contents of the problem. The base of a square pyramid having edges 30 mm and axis 60 mm long. So these are the dimensions. The base, each side measures 30 mm and the axis is 60 mm. Height from vertex to the center of the base is the axis that is measuring 60 mm. It appears as a rhombus in the top view while resting on a corner. So yes, specifically, very clearly is given, it has to rest on a corner of the base. So let us place the pyramid initially on HP such that one of the corners of the base, say this corner, is to the right side of the observer. So this can be done by placing the pyramid on HP with all the four sides equally inclined to VP and get the top and front views of the pyramid. Friends, I am going to write here a square of 30 mm side. This is a square and this is the top view of a pyramid. So I am going to just join the diagonals like this. Call these corners as ABCD. And here friends, all these edges, say edge through this point B, will have an angle of 45 degree with the HP. This is 45 degree, this is also 45 degree. And all the four edges are equally inclined to VP. We will call this as O, the vertex top view, and O1 the center of the base. Friends, after obtaining the top view, let us see how it looks in the front view. Friends, in the front view, we have to just project these lines from here, obtain these points A, B, C, D, etc. on XY. So this will be our A dash, this is C dash, this is B dash comma D dash. So this is B dash and D dash. And through this point, we will mark the height from the axis, that is from the HP. So this is having a height of 60 mm. So I am going to write a line here to show the dimension of 60 mm, the height of the solid. Friends, the line A dash C dash on XY represents the base of the pyramid which is on HP. So this is vertex O dash. Join these to all the corners. So I am going to join O dash to A dash, O dash to C dash, O dash to B dash and O dash to D dash. So friends, this figure will give you the front view of the square pyramid while resting on its base on HP. Now he says it has to rest on a corner such that it becomes a rhombus in the top view. Friends, if you have a pyramid like this, both the diagonals will have the same length. That is, AC and BD will have the same length. And now, if you slightly rotate it, keeping on one of the corners, depending on the angle of inclination, you are going to get rhombus for the same square base. So he has already given the dimensions of the rhombus. So friends, adjacent to this figure, I am going to construct a rhombus to the given dimension. He says it has got a width is equal to 20 mm. So rhombus in top view and the minor axis or the shorter diagonal is 20 mm long. So we'll construct a box here, 20 mm wide, and height is equal to this BD. And let us locate the four corners. That is exactly in the center of this. You will get a point, another point here, point, because they have clearly stated it is going to become a rhombus in the top. The base becomes a rhombus. So friends, Let me mark them as A, this point is B, this is C, and this is D. So we will write down the top view, how it appears in the top. It is a rhombus. Let us join it later on. Friends, now how to obtain these points? Friends, the position of C should be on this point, on point through this C. So I will write a vertical through this and locate this C dash, the position of that corner on HP, and through this point A, I will write a vertical line through this, so that I am going to redraw this figure here such that the base A dash C dash is to be marked here. So what I do, I just take C dash as center and radius equal to the length of the diagonal AC. I just draw a line to cut the vertical through this at this point. So this is going to become A dash, join A dash to C dash. And friends, this line is same as this A dash C dash. It will have a length equal to the length of the top view. So at the center of this, we can mark BD, that is B dash D dash, and draw a vertical line through that. So this vertical line is this OB, OD, and let me join them with this. So friends, this is O dash, the position of the vertex. This is BD, O1 dash is the center of the base. We can also show here O1 dash. Friends, now we have made or redrawn the front view such that the base, when seen from the top, that is ABCD, appears as a rhombus like this. Now friends, we will get the position of O dash at the top view of O dash by drawing a vertical line from there, a horizontal from here. This is the position of O, the vertex. Let us join O to ABCD. So when you are joining O to A, friends, you can see here, this OA is visible to the observer, and hence I am going to mark OA by a full line. And then OB, OD, they are the border lines of the solid. They are completely visible. Then you have got this. Friends, if you observe the front view, the pyramid is resting on a corner of the face. This corner is not visible in the top view. That is to say, C dash is not visible in the top view, and hence the lines connecting that to the corner are to be shown by dotted lines. So this will be the top view of the pyramid, with the base becoming a a rhombus in the top view. So friends, you can see here, in the front view we have got this triangle O dash, A dash, C dash, and if they ask you in the question, what is the angle made by the axis with the HP, simply extend that, and if you measure this angle, you can get what is the angle the axis is making with the HP. Similarly friends, if they ask you what is the angle made by the base with HP, that will be this angle. Suppose this is 30, this will be 60. If it is 45, this will also be 45, because the sum of these two angles should be 90, since the base and the axis are normal to each other. So you will be able to obtain even the inclination of the axis and that of the base with the HP. Friends, you have got this top view. Now if you observe the top view, friends, you will see that the shorter diagonal of the rhombus, or the minor axis of the shorter diagonal, is AC. So this is the minor axis or shorter diagonal, minor axis of rhombus, and that is now parallel to VP. Parallel to VP. It's not, it's parallel to XY, means parallel to VP. But as per the question, it should appear It will only appear normal to VP. So finally friends, I am going to redraw this figure such that the minor axis AC, which is parallel, becomes normal to VP. That means I have to rotate this figure to an angle of 90 degrees. So friends, let us construct this figure. So first of all, this ABC will construct. For the same dimension, friend, we are going to get all these 4 corners. So I will join them like this. And here the last point is A and this point is C. So this will be B and this is D. A, B, C, D you can take either in the clockwise or anti-clockwise direction. This is the vertex O and join O to B, O to A, O to D. You joined on this. Friends, here DC and this BC, DC and BC should be dotted line because they are not visible in the top view. So I have got this point is O1 and this AC, which was parallel to VP, this AC has become perpendicular to VP or normal to VP. So this figure, friends, will give you the final top view of the pyramid. And let us obtain the final front view of this pyramid. So let us start from this point one by one. So let me start with from A. Draw a vertical line from A horizontal line from A dash here. The point where those two intersect is the point A dash in the front view. So we'll call it as A dash. Next, draw a vertical line from B dash, B, and a horizontal line from B dash. The point of intersection of these two will give you B dash, the second corner of the pyramid. Similarly, C, vertical from C, horizontal from C, they meet here. This is C dash. Then friends, finally we have got D. Draw a vertical line from D, a horizontal line from D dash. The point of intersection will give you the point D dash. So this is D dash. Friends, we got all the 4 points. We will join them by straight line. So I will join A dash to B dash, B dash to C dash, C dash to D dash, and D dash to A dash. Friends, if you draw this figure correctly, this B dash C dash will be parallel to this and equal length, and this will be parallel to this C dash D dash. This is O1 dash, the center of the bottom face of the solid. And friends, finally we have to get the vertex. So draw a horizontal line from this O dash, a vertical line from this O. The point of intersection of these two will give you O dash, the front view of the vertex. Friends, let us join this vertex to all the corners. So we join O dash to A dash, O dash to B dash, O dash to C dash, and O dash to D dash. Friends, here you can just observe here, after joining all this, the portion between this is not visible. So, and I show this by a dotted line. Friends, this is how we obtain the front view of the solid. And friends, remember, there is a very important factor to be noted here. C dash, B dash is one of the shorter edges. C dash, D dash is another edge containing this corner C. And if you just look at the figure, they make, or the shorter edges make equal inclination with HP, that are denoted as alpha. Friends, I am very confident that you are all happy with the presentation I have made. And if you are happy with the presentation, do subscribe to my channel and you share this information with all your friends. Have a wonderful day.